I'll be using BGP for routing. As you know very well that we have gone through WIP, ICRP, static routing, OSPF. In OSPF we went through both versions, and I have told you that how will you enable OSPF version 3 and all, right? So now let's go for BGP. It will not take so long time for I mean to configure these things over here. Like for an example, see, rules are still same as IPv4. There is no single difference. Nothing. Are you getting my point or not? There is no single difference at all. Fine. Let me show you now something over here. Let's say that here I'll put all of them in a same AS 200, and here I'll put it in AS 100. R1 will be in AS, let's say 100, and let's say R2, R3 and R4 will be in AS, tell me, 65500 private AS. Fine. Start it from R1, router BGP 100. What is it saying? Because we didn't configure any single IPv4 address onto any single interface. So you have to say BGP in format of IPv4 address itself, and then say neighbor is my 2000:192.168:12 remote AS is what? What? Okay, 65500, right? In same manner, I'll move on R2, router BGP 65500, neighbor 2000:192.168:12:1, remote AS is what? 100. Fine. You will see that neighborship will come up. Show IPBGP summary. Oh, where? On R2. So you have to say BGP router ID. Nothing. It is not showing you over here anything. But if you configure it on all, in old iOS version, you will see that it will come up automatically in older iOSs. However, it should not come up because by default in BGP address family is configured only for IPv4. Do you remember default address family for IPv4? Hello, that we disabled sometime. But this IPv6 was using that default address family in older iOSs, but definitely here it will not be in use. So now to achieve it, what you need to do over here, go back to router BGP 100 over here. As you configured your neighbor command, that's fine. That will still be required actually. As you can see that we have already configured this neighbor command over here. After configuring this neighbor command, now say no BGP default IPv4 unicast. Disable your default address family, and also you can disable it. However, it is not mandatory, but I am disabling it, right? That no BGP default IPv4 unicast. After disabling this default address family, let me show you. You have to create address family only for IPv6 now. And then same as like you activated your neighbor in IPv4 address family, you remember in same manner in IPv6 as well you have to activate your neighbor. Like your neighbor command was this, and now in place of remote ASA activate. In same manner move on R2, say address family IPv6 unicast, and then that you configured here remote AS also activate. But remember that inside address family you cannot configure your remote AS. Like if you want to configure this command over here like this, here it will take it. It is accepting this command as well. See, however, it is not required over here. See, I'm removing it from address family. This come outside and then configure this command remote AS. Let me show you running config of this BGP now on R1. This is running config of R1. Fine. Move on R2. Show run type section router BGP. Here we have not activated, so we have to reactivate. Go to router BGP 65500, say address family IPv6 unicast neighbor, and then say activate. Now you will see that your neighborship will come up once again, but remember that this is really mandatory to activate your neighbor. So this time, see, in address family IPv6 you have activated your neighbor, and now your neighborship will come up. You see that on both sides it have came up. But remember that if you configure this command show IPBGP summary, it will not show you anything over here, because this command is used only for IPv4 protocol stack. This command will work only for IPv4 protocol stack. बार बारिश नहीं हो रही है? बंद हो गई? नहीं हो रही है। कितना हुई है? तो बड़ी। जबरदस्त आवाज तो आई नहीं। Okay, so it will not show you anything over here in the output of show IPBGP summary command, right? But if you configure, if you wanna see anything related to IPv6, then commands will be, bit different. Like command will be like this: show BGP fine. This is your command. Have you advertised anything into BGP? That's why prefix received it was 0. Apart from that, see, everything is same. Like neighbor's IP address version is 4, remote AS is 65500, message sent, message received, table version, input queue, output. Everything is same as previously. If you wanna see your BGP table, in place of summary, just press enter over here. So is it showing you anything over here? It means your BGP table is blank right now. It is not having anything in it. Then if you wanna see your neighbor, then after unicast, say neighbor. This is your command. This is what external link. EBGP neighbor. Remote router ID is 222 and everything is same. Neighbor 1 is active, is not multi-session capable, is disabled. Neighbor capabilities, route reference capability is there. Neighbor can also configure 4-octet AS number. Address from the IPv6 is also there. Advertised enhanced received capability, refresh capability, advertised and received and as you know, multi-session capability is by default disabled, right? So these capabilities are there, so all these things are there actually, but again TCP port number 179 will be in use, as you can see over here as well. Port number 179 would be in use. Right? Fine. After it, if you want to advertise anything into BGP, it's quite simple. Router BGP 100, go to address family first of all, and it's not always mandatory to add your unicast keyword as well, because it's already, or it's by default what, unicast, right? Then if you want to advertise anything, you can use network command, or same as IPv4 you can use if you want to use network command fc00:192:168:101:12:/64. Remember, if you are advertising anything with the help of network command, then rules will remain same as IPv4. I mean, that network must present in your local RIB. Now you can see this prefix available in the BGP table of R1 itself, right? So the command was unicast only. So I show BGP IPv6 unicast. That's it. See. Next stop is what? Dual call, and it is self-advertised. Weight is 32768 because self-advertised. Then you can move on R2. So BGP IPv6 unicast. Check it out. It has received it from 12:1. If you want to advertise over here itself, I mean the lane of R2, then router BGP 65500, address family IP, network, dual colon means self advertised. Now it will advertise it in the direction of R1. So now if you check, so IPv6 route, it has learnt via AD value is next hop. In next hop it will always specify you only link local address. Check it out. So IPv6 route, it has learnt it via BGP. Now if you wanna configure IPG peering in between R2 and R3, one more thing, check running config of R2. The router BGP 65500 neighbor is what? Tell me. 2000 colon remote AS will be. Then you have to go under, and then you have to say in same manner move on R3. Router BGP 6550, BGP router ID is what? No BGP default address family, then say neighbor colon activate it, and then say network. Then configure another neighbor as well. 30. Go to then move on. R4. Router BGP 65500, BGP, no BGP, default IPv4 unicast. Now neighbor, it happens in IPv6, don't worry. So after it, say address family IP, and then just activate, and then say network. Neighborship okay. Now move on R3. R3 will be receiving prefix coming from R4 as well as R2. Let me show you. Show BGP IPv6 unicast, enter. It is receiving one prefix from wow, next stop is not getting changed, is not it? Like prefix is coming from R1 to R2. When R2 is giving it to R3, it is giving it without changing its next stop. So next stop self will still be, I mean, because rules are same as IPv4, not BGP. Of course, we are doing BGP only. I mean, rules are same as IPv4. There is no single difference. Move on R2. Under address family itself, like when you configured your neighbor 23 12:3 in along with activate command, also say next stop. This is your IPGP neighbor, right? Then move on R3, and this time you will see that it will become best. Still it is not best, so do one thing clear. BGP IPv6 unicast star in. Now next stop has been modified, and this prefix is coming after crossing on R3. 102 is there, 103 is self-advertised, 104 is also there, but IPGP rule will also work over here. It means on R2 you will not get this 104. Is there 104? Of course it won't give it to you. I mean R2. If R3 is receiving anything from R4, it will not give it to R2. If R3 is receiving anything from R2, then it will not advertise that information towards R4. That is why if you move on R4 you will not get anything. Only 103 is there. There is no information about 102. There is no information about 101, because R3 will not advertise them towards R4. So again you will require to configure route reflector. So move on R3, because you have to configure R3 as a route reflector. So move on R3, and to configure route reflector, say router BGP 65500 address family IPv6, and then say neighbor 2000:192:168:23:1, and then route reflector client. Fine, no problem at all. Move on R4. Check it out now. but now their next hop addresses are not reachable, and here now you cannot use next hop self keyword. Again, you have those two options. I mean, that option only, like you can modify this next hop address with using route map. So if you want to use route map over here, you can use that. First of all, create prefix list for IPv6. In that prefix list, match only those prefixes to whom, I mean, for which you want to change their next hop addresses, right? You have to match those prefixes, but right now what can we do? We can configure it on R4 for all those prefixes which are coming from R3. So do one thing, create one route map with the name of next hop permit. Don't match anything, say set IP next hop is what? 2000:192:168:34:3. What happened? Sorry. Sit. This come outside, right? In place of IP, you have to mention IPv6. Then go to router BGP 655 neighbor 2000:192. Go to address family IPv6 first, then neighbor, and then say route map. And route map name is what? Clear? Now tell me, is there any requirement for me to do all other practicals of BGP?
बीजीपी में हम नेम कम्युनिटी के अंदर एक कम्युनिटी बोलेंगे, इंटरनेट कम्युनिटी,
वो सबके लिए होती है. If you want to advertise your prefix towards all, whether it is IPCP neighbor or APCP neighbor, then it is internet. Fine. So tell me, now will you be able to configure all these things by yourself? Like everything is same. You just need to see. I have also taught you that how to apply your route map, how to configure your route map for a neighbor. Is there any problem now in BGP? Just tell me. Like here, router BGP 65500 address family IPv6. As you configure this neighbor command, if you configure route, I mean question mark in place of route map, see. The same things, same options, same wait per neighbor, route map, next hop self, override, I mean this prefix list, right? Remove private AS, route reflector client, right? Send community, I mean all these soft reconfiguration, unsuppressed map. Do you remember? So all these things are available. Allow ASA and advertise, like if you want to configure advertise map.
राउट सर्वर क्लाइंट क्या है?
Advertise map is not there, I think so. There is no advertised map. Over there we were having per neighbor advertised map as well, but I mean till now they have not announced it in IPv6. You are asking about route server client, right? I haven't configured it before, so I can't say anything about it.
फैक्टर के साथ तो लेना
Might be. Right, guys? So in this way you can configure this BGP. So I don't think so that there will be any problem for you guys to configure BGP over IPv6 because it's completely same. Commands are same. You just need to take care that in place of IP you just need to mention IPv6. Apart from that, everything is same. Right? So if you want to ask me anything related to it, please let me know. Now next topic in IPv6 is going to be after BGP, that how to configure ACLs, how to perform data filtering, not route filtering. I'm talking about data filtering. Like do you remember that with using ACLs you could drop any type of traffic onto interface during CCNA? You denied HTTP, TCP, Telnet, something like that, FTP. Yes. Like you configured an IP access group command. Do you remember? In same manner, you can also apply IPv6 ACL onto interfaces. Like I don't want to allow Telnet onto R2s F0 by 0. So I can move on R2. I can say IPv6 access list and then its name, test, enter. Permit deny statements will remain same. Like if you say deny TCP any EQ telnet, you understand? And then permit IPv6 any. This is like permit any. Hello, permit IP any. If you have denied something, then you have to permit all others. And here rules will remain same as IPv4 ACLs. Like again, sequence number will be allocated to each statement in the increment of 10. Go to your interface FA0 by 0 and then say IPv6 traffic filter and then ACL name, like it was. Now direction, in or out. So I wanted to drop all incoming telnet sessions onto R2's F0 by 0. So in this way you can create these IPv6 based ACLs and you can apply them. Even you can also block ICMP as well, right? I will prove it. Show IPv6 access list. Let me show you. See, sequence number 10 and then 20. Now if you wanna take telnet of R2, however R2's prefix is there. See, R2's prefix is there 102. But if you say telnet, you understand? But if you move on R2, if you have to remove it from this interface, remove it, trying, it's open but password is not set. It means now it is successfully done. Hello, it means your telnet was successfully done. The only thing which is required now, just configuration of password on R2, because without authentication you cannot take telnet of your devices. So now in this manner you can block any type of traffic, any type of data in IPv6. In this way you can configure your IPv6 based access lists. Any problem? Fine. After it, let's go for IPv6 tunnel. IPv6 tunnel. Let's say that here in the lane of R1 you are using IPv6, but And also yes, on our for, let me do one thing, change host name. Oh my god. Okay, then let me recreate this topology, right? Fine. So here in the lane you can see that we are using IPv6, and let's assume that wait just a moment, that these routers like R2 and R1, in their lane we are using IPv6, right? And they are connected with an ISP, and ISP is still using IPv4. Let's say here you have got 101.1.10, here you have got 101.1, then here you got like 102.1.1, and let's say that here you have got 102.1.10. Fine. Is there any problem now? Great. Let's assume that this R1 is placed at Delhi site, and this R2 is placed at the end of Gurgaon site. There are two different sites, and in the lane of each site we are using IPv6. You understand? In the lane of each site we are using IPv6, but
इसमें NAT अगर करें
it's not possible. It's not possible. I'll let you know. See, thing is, we can translate IPv6 headers back into v4 headers, and from v4 headers to v6, and it is not easy. This is not easy. So usually we do not prefer that, because we also want end-to-end reachability, right? We want that their lane users must be able to communicate with each other. You understand? So of course, if your packet is having source and destination as IPv6 addresses, then how will it be possible for that network to allow that packet who is running IPv4 only? Fine. So this time let's start doing this configuration. This is R1. Oh, sorry. R1 is already there, see, and R2 is also already there, and then finally this is what? ISP. So let me do this configuration of ISP first, and then I'll be doing configuration of all other devices. See, at the end of ISP I'll allocate these IP addresses only, like FA0 by 0 IP address 101.1.1, and on its FA0 by 1. That's it. Fine. Even you will not get the console of ISP router. The only thing that you will get is end-to-end reachability, right? So now let's configure this R1 first of all. as per this diagram. FA0 by 0 IP address is going to be 101.1.10, and then enable IPv6 unicast routing FA0 by 1 IPv6 address FC00 colon 182.101 dual colon 1/64. Any problem? So in the lane of R1, in the lane of Delhi router, we are using IPv6 addressing, and then let's move on R2, and on R2 as well, go to FA0 by 1 IP address 102.1.10. Then on to FA0 by 0 IPv6, sorry, yes, but before that, IPv6 unicast routing, go to FA0 by 0 IPv6 address FC00 colon 192 colon 168 colon 102 dual colon 1/. So IP interface B. So IPv4 address is configured, as well as IPv6 addresses. IPv6 address have also configured on both devices. Then the very first requirement before going to configure IPv6 tunnel in between these two remote sites, that you must confirm which is end-to-end reachability. Very first thing that you must confirm is end-to-end reachability. So from R1 you must be able to communicate to R2 with using their IPv4 addresses. This is very primary requirement. Move on R1 now, and on R1 you can try to see your route, and if you try to communicate with 102.1.10, of course you will not communicate with it, because your R1 do not have any path, any route to reach this 102.1.10. So do one thing, configure a static default route in the direction of ISP. Next hop address will become 101.1.1 now, and in same manner you will be doing this configuration at the end of R2. Configure a static default route next hop will become 102.1.1. Show IP route. Fine. And now you can try to communicate, you can try to ping from R1 to R2, and which is 102.1.10. Fine. After knowing that, okay, now we have end-to-end reachability, then we can go for tunneling now. So we will be configuring now IPv6 tunnel. So on both ends I will require to configure one tunnel interface, and will also require to allocate an IPv6 address to those interfaces. And remember that if you are going to allocate an IPv6 address to those tunnel interfaces, that network must not be in use already in your network, right? That should be a separate network, but make sure that on both ends it should belong to same network, right? Tunnel address must belong to a same subnet. Go to tunnel 1, say IPv6 address. Let's say here this time I'm going to configure FC00 colon 192 colon 168 colon 1 dual colon 1/64. So I'm not using this subnetwork anywhere. And on R2 I'll configure 1 dual colon 2, and then I have to define tunnel source. Tunnel source would be my 101.1.10, and tunnel destination will be my destination, which will be 102.1.10, and tunnel mode must be IPv6 IP. Means that over IPv6 header you have to add one another IPv4 header, just like GRE over IP, right? GRE over IP means over IP header you are adding GRE header. In same manner, IPv6 IP means over IPv6 you will be adding one another IP header, and then go to R2 as well, configure one another tunnel interface over here. Say IPv6 address fc00:192.168:1 slash, say tunnel source 102.1. tunnel destination 101.1.10. tunnel mode is fine. Now you can see show IPv6 interface brief. This is tunnel interface show IPv6 route. This network 1:/64 is connected via tunnel. So remember that whenever any traffic will go through the tunnel, it will add another IPv4 header onto it. I mean, your IPv6 based payload will be encapsulated by another IPv4 header, and in that IPv4 header, source and destination IP will be depending on your tunnel source IP address and tunnel destination IP address. It's same as GRE. The only thing, in place of GRE header now it will add IP header over IPv6. Right? So from here, from R2, now you can try to communicate with the tunnel IP address of R1, which is 1. Check it out. Sorry, it's not it. And definitely it will go via, you can check it out, like you can capture it from R2. Once again try to communicate with that. You open it now, open this packet. See, it is generated by IPv6 1:2 and destination is what? 1:1, because from R2 we try to communicate with the tunnel interface of R1. Hello, that is what it is having over here. And then this IPv6 header has been encapsulated by another IPv4 header. So whenever ISP, and one more thing, see here its protocol field is what? 41. What does it mean that IP has to hand over it to the IPv6? Means IPv4 has to hand over it to the IPv6. Because the protocol number of IPv6 itself is 41. Understood? So this is IPv6 and this is protocol number 41. Fine till here. There should not be any problem. Now after doing this configuration, you do one thing, configure any other, any routing protocol, any one of the routing protocol, whether EIG, IPv6 or OSPF version 3, whatever you want. Like if you want to configure OSPF version 3, you can do it. Like move on daily, say router OSPF version 3 1, address family IPv6, say router ID, and then go to interface fast Ethernet 0x1 OSPF version 3 1 IPv6 area, then go to tunnel 1 as well. In same manner, move on Gurgaon, router OSPF version 3 1, address family IPv6, router ID is what? Fine. Then go to interface FA 0x0, say OSPF version 3 1 IPv6 area 0 interface tunnel 1. Neighborship is done. Once neighborship will come up, it has learned the lane of, and see, it will go via tunnel. So if you want to try to communicate with the lane of R2 now, which is 102 dual colon 1, in source also you can put your FA0 by 1, I mean the lane of R1, and then you can repeat it. And everything is going via ISP. But if ISP block protocol number 41 over here, tunnel will be blocked. Understood? So in this way, we can configure IPv6 tunnel. This is called IPv6 tunnel. But remember, it is adding 20 bytes long extra overhead, because 20 bytes. IPv6 was already containing 40 bytes, but IPv4 header will be 20 bytes long header. So definitely it will add 20 bytes long extra information, extra overhead, but finally you can get this type of communication. You can get this type of reachability in between two remote offices which are running IPv6 based subnetworks, but they are connected through a IPv4 enabled network. NAT PT is also there, but I don't think so that it will be required for you. However, I can do this configuration, but remember that you will not be able to understand that. Even it is not in use in production. In production, we are always using only dual stacking. We are using dual stacking. And what is the meaning by dual stacking? That we are using both stacks, IPv4 as well as IPv6. So if you want to access anything with the help of IPv4, then we can access that. If you want to access anything with the help of IPv6, then also we can access that. But it is also possible to perform netting in between IPv4 as well as IPv6. You understand? So this time I'm going to perform that actually, right? And to configure that, let me do one thing. Let me recreate this topology. Now on R1 I'll be configuring its address as 111, which will be loopback address. At the end of R1 it will be 12.1.1, and at the end of R2 12.1.2, and then again definitely I'll be using IPv6 address in between R2 and R3, and it will be something like this: 2000:192.168:23:2, and definitely at the end of R3 it's 23:3, and in the loopback of R3 will be containing, like for an example, even here in place of 2000 you can also make it like private IP, like which is FC00, right? And here on R3 you can do one thing: you can make it FC00:192.168:3:3/128. let's say it is on /128. So from the loopback of R3, now we want to communicate with the loopback of R1. Now remember that in a single header it is not possible, like source address is v6 and destination is v4. It's not possible. Never ever. In a single header, like if you are adding IPv4 header, then in that source and destination both must be IPv4 addresses. If you are adding IPv6 header, it means source and destination must be IPv6 address only. So basically that is why generally we do not use it in production networks. You understand? Because you have to predefine it that okay, the IPv6 address for this v4 address will be this. You have to define it by yourself, right? So now because you want to communicate from R3's loopback to the R1's loopback, which is v4 address, so you need to assume that what will be IPv6 address of 11111. So from R3 you will try to communicate with that v6 address, but actually you will be communicating with the loopback of R1, which is IPv4 address. So basically NAT PT in IPv6 is done with the help of this prefix only by default, or this is in documents actually that you should use this 2000 :/96. Means first 96 bits will be reserved and remaining 32 bits will be copied from IPv4 address. Remaining 32 bits will be copied from IPv4 address. So you need to convert your IPv4 address into it. So 2000/96 means first 96 bits are already configured. Remaining 32 bits will be copied from your IPv4 address, which is, tell me, 1 1 1. If you convert it into the binary, it will be like 0 0 0 0 0 0 1, one more 0, and then 0 0 0 0 0 0 1, 0 0 0 0 0 0 1, then 0 0 0 0 0 0 1. Fine. So if you convert it into hexadecimal now, so it will be, I think so, like 2000 :101 101:101. The leftmost will be also 0, because see, first 4 4 4 4 4 4 4 4, right? So it will become 0101, then again 0101, but the leftmost 0 do not have any significance. That's why I have taken 101 101. You understand? So if you convert this IPv4 address back into IPv6 in terms of 12,000 :/96, it will be 2000 :101:101. So basically, from R3, whenever you will try to ping from R3, at that moment your source will be, tell me, FC00:192 168:3 and destination will be 2000 :101, sorry, 101:101. This will be your destination. Now it will be received by R2. At that moment also source and destination will remain same whenever this R2 will receive it, right? But now R2 has to perform translation over here. It has to convert it into IPv4 now. Definitely we know that what will be destination will be 111, but what will be your source? Of course you have to change your source as well, right? So what can we do? We can think here that, okay, let's take source as 12.1.3 12.1.3, which is not in use in between R1 and R2, but it is directly connected to R1. However, we can take any IPv4 address, but at that moment on R1 you will require to give a route for that particular address. But this time, because this 12 subnetwork is directly connected to R1, so it can send this packet back towards R2 automatically without specifying any static route at the end of R1. That is why here I have taken source as 12.1.3, and after then destination will be, of course, now this R2 must have this route in its routing table, that how to reach 11111. Then finally R1 will receive this packet. R1 will receive this packet, and after receiving this packet, R1 will respond back, and at that moment source will be and destination will be 12.1.3.
यहाँ पे इसको
Now,
करना पड़ेगा।
yes, now R2 will receive this packet over here, but before transmitting it towards R3, it must translate it back, and at that moment source must be 101:101, and destination must become FC00: tell me But this time R2 must have in its IPv6 unicast routing table this route that how to reach this 3 dual colon 3. Is not it? Hello. So we have to go through step by step. First of all, R3 must have this route 2000 dual colon 101 101, and okay, let me have the console of R1. I have to configure their IP addressing first, and then we will go ahead. Is it visible?
सर इसका 76 कर दो
What 76 कर दो?
ये सोर्स वहाँ पे आईपी थोड़ा गलत लिखा गया है
Where?
डायग्राम
192.178
सोर्स या
Fine. We started from my R3 itself, IPv6 unicast routing, FA0 by 1. IPv6 address, it's FC00 colon 192 colon 168 colon 23 dual colon 3 slash loop back 1 IPv6 address FC00 colon 192 168 colon 3 dual colon 3 slash this is the loop back, right? So IPv6 route. It does not have anything over here, right? And then do one thing, say IPv6 route 2000 dual colon slash, you can take even 16 as well, or configure a default route, right? Hello, in the direction of R2. So next stop will be FC00 colon 192 168 colon 23 dual colon 2. Fine guys, then move on R2 and so IPv6 unicast routing, and like on to is FA0 by 1. So IPv6 address FC00 colon 192 168 23 dual colon 3 2 slash 64, and then on to its FA0 by 0. IP address will be 12.1.2. Fine. Now it must have that how to reach 11111. Is not it? So that it can transmit those packets in the direction of R1. So I have configured that. So see, show IP route is there, show IPv6 route, but it does not have that how to reach 3 dual colon 3. So say IPv6 route FC colon FC colon 192 colon 168 colon 3 dual colon slash 64. Right, and next stop address will be FC00 colon 192 colon 168 colon 23 dual colon 3. Is not it? Now say show IPv6 route. Fine, it is there. Now move on R1. Interface FA0 by 0 12.1.1. Loop back 1 IP addresses. Here we don't need to give any path, any route, static route, because 12 network will be directly connected, because whenever it will respond back, it will respond to 12.1.3, right? So it is directly connected to FA0 by 0. So there is no need to configure any route. Now move on R2 and configure netting. To configure netting, first of all you have to say IPv6 NAT 2000 NAT prefix and then 2000 dual colon slash 96. You have to enable this prefix first of all. This is very first command that you have to enable. You have to tell to your router that okay, you will be performing translation with using this prefix. However, you can take anything, but in documents, according to the INA, we have to use this prefix for performing NAT. But you can take anything like 3000, 4000. Accordingly, you have to modify and accordingly you have to ping from R3, right? because if you are having like 2000, then you have I just converted it back in form of 2000 only. If you are taking 4000, 5000, then you have to convert it accordingly, right? So after it, now go to interface FA0 by 1, say IPv6 NAT, then go to FA0 by 0 also, say IPv6 NAT. Then after it, because we are doing static NAT PT, so we have to tell this router that which IPv6 address will be converted in which IPv6, right? So for that purpose, here there is a command IPv6 NAT IP translation, sorry, V6 to V4, V6 to V4. So you have to convert your V6 to V4, and source will be, let me tell you, I think this time source will be your FC00 colon 192 colon 168. You understand? Wait. V6 to V4. Okay. Let's say 2000 colon 2000 colon and it dual colon, sorry, 101 colon 101, in which IP 1, and then IPv6 NAT V4 to V6 source will be 12.1.3, and it will be converted back into FC00 colon 192 colon 168 colon 3 dual colon 3. Right? So here you given these two commands only. As I have already mentioned over there, see, I have already mentioned all these things, that it has to translate it in this way actually, and accordingly I have given these commands. Now if you move on R3, try to communicate with 2000 12 colon 101 colon 101 when source is your loopback 1. It is not working fine. Of course, it how everything. I think on R2 we have given these commands incorrectly. This one, sorry, no, and this, and no, and this. Give it in reverse manner now. IPv6 NAT V6 to V4. Source is FC00 colon 192 colon 168. You understand? And then 3 dual colon 3, and then you have to convert it back into 12.1.3, and then IPv6 NAT V4 to V6. Actually it will be good. Actually this statement is correct, 111, because whenever it will come back from there, at that moment its source will be 1111 and destination will be this time 2000 colon, tell me, dual colon, actually 101 colon 101. And now after doing this statement, after giving this statement, so think what is happening, how we give, see, right? So in this way you have to give this statement. You show history. We said here that if V6 address is this, because whenever it will receive very first packet, its source will be 3 dual colon 3 itself, right? So it has to convert it back into V4 address, and it will be 12.1.3, right? And whenever it will receive any packet which is coming, which is V4 address, right? So in that if it is receiving any v4 packet, in that its source would be 1111 and destination I mean it has to convert it back into, hello, it has to see, this is static NAT actually, but here you will call it static NAT PT. Hey, do you remember NAT PT means protocol translation? Because you are replacing your header, you are replacing v4 header with v6 header. Even you can see here, you can configure this command debug IPv6 NAT and then move back again on R3, try to ping with it. It will show you that it is translating it. You see, it received one ICMP packet, it was having source as this, it translated it back into 12.1.3 and destination was this, but it has to translate its destination as well, right? It has to translate its destination as well, and destination was 12.1. Hello, destination was 2000 dual colon 101 colon 101, so it has translated it back into 12.1.3, right? So basically, you see, sorry, this is source, this was source IPv6, it has converted it back into 12.1.3, it has translated it, and destination was 2000, this IPv6 address, it translated it back into v4. See, 111. When packet came back, at that moment source was 1.1.1, it translated back into IPv6 in this manner, and destination was 12.1.3, it has translated back 3 dual colon 3 IPv6. Again it received another ICMP packet, source was this, translated back into v4, destination was this, translated back it into v4. Then again it received ICMP echo reply. At that moment source and destination were v4 addresses, and it has performed this translation in this manner over here actually. So I hope that you people have understood it, that how to configure it. But see, for each IP address you have to give these statements, and it's not going to be very easy. However, you can do it, but see, it's not possible, right? In production network, yeah.
अगर वाई शॉपिंग देखेंगे तो पहले लिंक में सिर्फ IPv4 का वो लिखा है, और दूसरे लिंक में सिर्फ IPv6.
Exactly. You can do that actually. Let me show you. First of all, capture this one. Open window of this. Then go and capture this link. And then open this window as well. Right? And then do one thing from R3. Once again, ping with it. Second window must have IPv6. See, only IPv6. Check it out. Before layer 2, right? I mean, after layer 2, it is having only IPv6 header. Then open this one, first one. See, source was 12.1.3, only v4. That is why we are calling it as protocol translation, right? PT. Anything else that you want to learn in IPv6 now? We have covered. We have covered now most of the things of IPv6. Now we will start MPLS, but not today. We will start this MPLS from tomorrow, because some other people will also come tomorrow. Most of the people are absent. 6-7 people are absent actually. So they will also be present tomorrow. Because if I start my MPLS by today itself, इसको क्या हुआ? तुझे क्या हो रहा है? नींद आ रही है? If we start MPLS by today itself, then the problem will be like for them it will not be possible for to understand this MPLS again, because like basics are really important. Because MPLS is completely new technology. So
सर कर ले करो, आज ये भी हजम कर लेंगे थोड़ा.
ये तो इतना है, ये तो छोटा सा है.